All right, let's get started. How's everyone doing? You guys a little nervous? Okay, this is the review for 4150 algorithms. I'm Stephen, so if you have any questions, just raise your hand. I'm going to make this very casual, so I prepared a PowerPoint. If anybody's interested in the PowerPoint afterwards, let me know and I can post it. Please do. Yeah, those do.
I don't know that much question. Just go for it, man.
Okay, so we're going to divide up into 4 different sections. Important facts, Joe kind of mentioned these yesterday in class. When the review is, the average grade on this test that's coming up is 66. It is next Tuesday, May 1st. You can bring 2 sheets, front and back, so 4 sides, typed or written. I would suggest that you use your sheet for the midterm as 1 sheet and then make a new sheet for the second sheet, for everything we've learned since then. Do not use a red pen on the test. That's what we grade with. So you can use a black pen, I would suggest, or a pencil. A hint is I would be on time, and when you get here, you're going to have to put all your personal items on the floor. The test is going to be in one-on-one, and we're going to try to get a second room so everyone won't be so cramped and everyone can sit apart from each other. But we don't know which room that's going to be yet. And then you'll have till the end of the week to go and see your final in Joe's office, but you can't take it with you. Okay, so everyone always asks me, yeah, go ahead.
I have a question on the curve. I was told Joe there's like an after.
Joe possibly will do a curve. He'll curve up, he won't curve down. So if you get 90%, he's not going to curve you down and say, well, there's a lot of 91s and above, so you're going to get a D. He'll never curve you down, but he possibly will curve you up.
By how much?
He doesn't even know until he sees the natural flow of the grades. And then he tries to find natural separations. And he tries to make all the grades average about 3.0, 3.1. Okay, so what should be on the test? I'd put the complexities, big O, omega, theta, tight bounds and loose bounds, know the difference. The order of complexities, all those from constant, clear down to factorial here. The master theorem, just calculate log base B of A and D, whatever is the greatest, put as the exponent on n, that's it. If it's a tie, then, put n to the log base B of A, put n to the D log n, yes?
He said he's going to put the master theorem on the exam.
Yes.
Does that mean he would also include the conditions, like if
yes.
A is less than B or whatever? Yeah.
Yes, he'll put the whole thing on. I would put it on your test anyway. Just to be, who knows, he may forget. So I just cover your own behind and put it on yourself. But I have the master theorem memorized. I just think that you calculate log base B of A, you calculate D, whatever is the largest you put as the exponent on n. If it's a tie, then you kind of combine them together and put into the D log n. So I just memorize it, and I don't have to worry about it. But put it on just in case your memory slips. I would create a table like this. I didn't finish filling out this table, so I didn't have time. But it has the best, average, and worst complexities, and maybe a column over here of notes of all the algorithms we use throughout the class. I filled in the sorts, for example, but do something like this and fill in the table complete and impossible. That'll help you. You don't know what he's going to throw on the test, and you're going to need the complexity of something. This is just some more stuff to fill in if you happen to have time. I just threw in some animations of the quick sorts, of the sorts. You're going to need to know how the sorts work internally. He may ask a question. He talked about 4 main sorts. You're going to need to know how they work internally, based, you don't need to know the details of the code, every line of code, but know how they work internally. And then you can answer any questions if he refers to them. Merge sort separates things in half, and then it combines them back together. Remember the merge sort with the optimization. You compare the last element of the left side to the first element of the right side, and if it's lower, then you don't have to compare anything. So it saves a lot of time. Insertion sort. I remember insertion sort because I think of the array in the two separate sections, the part I have sorted and the part I haven't. And insertion sort is I'm just grabbing a random item and I'm inserting it, quote, the word insertion, I'm inserting it where it goes. And then we have selection sort, I'm selecting something that hasn't been sorted, selecting the next one that goes in. So that means you have to go through the complete array because you're selecting what goes next and then putting it and then selecting. So the names are pretty obvious on what they do. So try to understand how these sorts work. Graphs, know what a DAG is. Complete graphs, strongly connected components. Know what the difference of a path and an edge is. Anybody have questions on those? Binary trees, priority trees, depth first search against breadth first search. Metagraphs, Prim's versus Kruskal's algorithms, the cut property, and there's many more. Those are just some I thought of. RSA against ESA, EAS, P times Q equals N, and so on and so on. Anybody want to go over any of the details of that? Okay. NP complete, P would definitely be on the test. You might want to put a little drawing like this on your cheat sheet just to remind you how it works. Joe has a drawing that he has. I tend to like this drawing here. Just remember that NP complete.
Just toggle the HDMI. That's all it works.
Remember that the NP complete is the union of NP hard and NP. And also remember that the candidate algorithm, you always reduce the candidate algorithm.
The slide stopped working?
No, I'm just wondering if I wrote this backwards.
No,
Yeah.
no, it stopped
I
working.
wrote this
everything.
backwards. As soon as I started reading it, I realized I wrote it backwards. So disregard this slide.
It's broken here now.
Excuse me?
It doesn't work here now anymore. No signal.
You would have said.
Oh, we're good.
Okay. So disregard this one. I wrote it backwards. Don't make that mistake. I'll have it corrected before I post it. And some other subjects, modular arithmetic and exponentiation. It will be on the test. Dynamic programming, greedy algorithms. Yes?
So the traveling salesman is NP hard, not NP complete. What is it? NP hard exactly?
Well, the one form of it is NP hard. The optimization is NP hard. The search part is NP complete.
Okay, because it's not a search, or it's optimization part is not a search algorithm, that would be NP complete, because that's one of the stipulations.
Repeat that again?
So non-search algorithms that are really hard are just NP hard, but if they follow the criteria and you know, like the polynomial verification algorithm criteria, all that stuff, then they are part of NP complete. Never mind.
Just consider the search portion and where that fits into the scheme of things, and not the optimization portion. And consider where that would fit. And the search portion of traveling salesman is NP complete. divide and conquer, disjoint sets, and caret subu. So here is the final exam. As he wrote on the previous exam, it's a closed book. This one has 17 questions. He said that the future one, the one for this semester, will have 25 questions, 4 points each. So it will be slightly different. If you have any questions, remember to raise your hand during the test. Don't miss a problem because you didn't understand the question. So don't hesitate to raise your hand or come down and speak with the TA or Joe himself. So here's the first question. Use the master theorem to derive a big O bound on the following 4 recurrences. In each case, T of 1 equals O of 1. So what would A be? A is 8, B is 3, and D is 2. So to resolve this, you're going to say the log base 3 of 8, and that would equal what? 2. Just a little bit under 2. Log base 3 of 9 would be 2. So we just know that it's a little under. So a lot of these you don't have to calculate the exact number, just know that it's a little bit greater or a little bit less than a number. And then D is 2. So since D is larger, it's going to be O of n to the D, which is 2. A is 9, B is 3. In log n, for that you can calculate that D is just a little bit more than 1. You could call it 1 plus epsilon or 1.1, however you want to look at it. It's going to be a little bit more than 1. Log base 3 of 9 is 2. So the answer would be O of n squared here. In O of log n, and then O of n. Any questions on any of these? So I know you're writing down the answers. I'll try to stay on this sheet long enough for you guys to write the answers down. If I jump, just let me know and I'll go back so you can.
You're just going to post the whole presentation.
He is going to post it too, but some people like to write them down as I give them. Okay, suppose that you want to create an RSA public-private key pair. You begin with 2 prime numbers, P equals 5, Q equals 13. Answer the following questions. What is n? How do you calculate n?
Is P times?
P times Q. P times Q is 65. How do you calculate E? GCD of what?
E minus 1 times Q minus 1.
Yeah.
So
With E equals 1.
Okay. P minus 1 times Q minus 1, so we get 48. And then to get E, that's how you get phi. Then to get E is you take the GCD phi and the smallest number you can, where the GCD equals 1. And here it would be 5. If you use 1, 2, 3, or 4, the GCD wouldn't be 1. Well, you can't. 1 isn't an option, but 2, 3, and 4 would work. And then to get the value of E, you take the inverse of 5, mod phi, to get 29. Inverse of 5 mod phi, which is 48, and you get 29, and that's how you get D. So D is 29. And then now we want to encrypt, and so we take 3, which is our number, take it to the power of E, 5, mod it by N, 65, and we get 48. And then reverse it, that's not a question, but to reverse it, you take 48 to the power of D, mod n 65, and you go back to 5. And try it on your calculators and it should work. Any questions? I almost can guarantee this will be on the test. I would put money on it. So you're probably going to get asked this exact question with different numbers. Write a recurrence relation that expresses the running time, T of n, of the method f below, where n is the length of A and A is not empty. So we're looking at this algorithm here, and we need to calculate what T of n is and what T of 1 is. So what is A? Okay, A is 2. Does everyone agree with that?
Yeah, because there's 2 recursive calls.
2 recursive calls. And what is B?
2.
B is 2 because?
You divide the array by 2.
We're dividing the array
size,
by 2.
The size of the subproblems are half of the original
We're
problem.
dividing it by half up here, and we're taking the second half down here. Has everyone read this test that's here? Or are you guys reading it for the first time?
First time.
First time? See, if you've already read it, I could go faster. If you haven't read it, then I have to go a little slower so you can read through the algorithm to make sense of it. So, this section here takes A and it copies the first half of it into a second array. This section here takes the second half of the array, copies it into a third array, which is called, what, A2. So the first half goes into A1, second half goes into A2. Here's our 2 recursive calls. So D is going to be what? D is going to be 1 because it goes through the whole array once. So 2, 2, and 1. And T of 1 is O of 1. Yes?
Sorry, why is D 1?
D is what?
It's because it's constant.
Why does it do that? How are we doing there?
Not supported. Hit the reset again.
Go through what Joe goes through.
Just don't touch anymore.
Just don't touch anything.
Alright, it's good.
Okay. So D is 1 because you're going through the complete array one time. You go through half of it here, you go through the other half here. So you've looked through all the elements of n. So to calculate D, the last section of that equation up there is O of n, is the complexity of everything except the recursive calls. So the complexity of everything here except these 2 things right here. You erase these 2 things, what's the complexity of everything else? And it is n, O of n. Any questions on that? Any more? You guys look really nervous. Raise your hand if you're nervous for this test. Raise your hand if you think this is a really difficult class. People told me all semester this class is so hard. So, hopefully, what was that?
It's the easiest class I've ever taken.
So, I'm trying to make it easier for you, so just, like I say, ask questions. If you have any questions, let me know. I will be, the TAs are not on duty anymore for the rest of, until the test, but I will be here available. Feel free to email me questions or come see me in my office at 3421. Or I'm going to post also this PowerPoint. So just let me know. I'm trying to help you guys all get 100. So if not 100, maybe 99. So Okay, question 4. Another thing I suggest for the test is, I was hoping that you guys would have taken this test before you got here. Because then you could have seen how difficult it is, thought about it yourself. When you read a question and then read the answer, you don't have to think. You just, oh yeah, that makes sense. So I was hoping that people would have taken the test beforehand. An alternative you can do is change the questions. What Joe possibly will do is take a question like that RSA and just change the 2 numbers. So go home and get those numbers and change the numbers and then do the new question yourself. Create new questions yourself from these and then do them yourself and make yourself think about it. Okay, question number 4. Indicate whether or not each of the following statements is true or false. Assume that all graphs are directed and unweighted. I would suggest on your test, write a little graph describing the type of graph we're using. So make a little graph of 3 or 4 vertices with edges with, that are directed with arrows and non-weighted, just so you have a visual orientation of where you're at. And then ask the questions, and when you ask the questions, you can look at your little graph that you drew. The metagraph obtained by running the strongly connected components algorithm will always have a single source and a single sink. Raise your hand if it's true. Raise your hand if it's false. Raise your hand if you don't know. Anybody want to explain their answer? Yes?
Running strongly connected components and making a metagraph turns it into a DAG with a single source and a single sink.
Okay. And your answer was true or false?
True.
What's your answer?
False, because a DAG doesn't necessarily have to have a single source or a single sink. So yes, it's true, it's a DAG, but you can draw a graph that you can get the metagraph of.
Who raised your hand back there? Yeah.
Yeah, it's the same thing.
Same thing?
Yeah, she did.
Who said false? Who was right? Okay, there will always be at least one source and one sink, but there can be more. And that's what she said. Right.
Yeah. That's more succinct.
Following a depth-first search, it is possible for one vertex to have pre-post times of 5 and 17, and another vertex to have pre-post times of 10 and 28. True or false? Raise your hand if it's true. Raise your hand if it's false. Raise your hand if you're not sure. Raise your hand if you didn't raise your hand.
I think it's true.
Okay. You say true?
Well, you just decided halfway. I just had to increase the weight.
Okay. Who wants to argue either answer?
Well, I mean,
What's your answer?
oh, it's true.
Because?
The only thing that we know about pre and post times is pre has to be before post. And they can't have like the same numbers. So.
And visualize doing pre and post times on a graph, and if you could get these numbers. First of all, try to see how they fit. Is it 2 numbers inside of 2 other numbers? Or is it 2 numbers that follow 2 numbers? Or are they rotated like this?
Like that.
They're like this. Is that possible? Now think about it. Is that possible?
Oh, you'd have to return. Okay.
Matt says no.
I changed my mind now.
Yeah.
You're saying no.
28 stuff.
Answer false.
Because if you're going down, you have to come back.
This is impossible. See the table on page 89 of the text for an example. Okay, the depth-first search of algorithms may fail to visit every vertex. The depth-first search algorithm may fail to visit every vertex. Raise your hand if it's true. Raise your hand if it's false. Raise your hand if you don't know. Depth-first search calls explore repeatedly for all vertices. Remember, depth-first search is the main program, and it calls explore. So if there's a separated part of the graph that's not connected, or there's a part of the graph that explore can't reach, depth first search will recall that new section. Does that make sense? So depth first search keeps call. Now explore may not explore every vertex, but depth first search will. Okay, indicate whether or not each of the following statements is true or false. Assume that all graphs are undirected, connected, and weighted. Close your eyes, imagine that graph, draw it on your test, undirected, connected, and weighted. And that all edge weights are positive, so no negative edges. There is a graph such that when Dijkstra's algorithm and Prim's algorithm are both started at the same vertex, the first edge chosen by Dijkstra's algorithm is different from the first edge chosen by Prim's algorithm. Raise your hand if it's true. Raise your hand if it's false. Who wants to argue the truth?
Can we review Prims?
Yeah.
Prims is just like the shortest.
Well, they're both shortest path, but Prims does it differently. Like if you can have negative edges in Prims.
They both start with the.
Prims keeps track of a section of the graph and it adds to it, and you pick the smallest edge coming. First of all, you pick the smallest edge coming out of the first vertice. And now let's say we color those first two vertices yellow. Now the second edge is the smallest edge coming out of one of those two vertices.
So
now we have three. Now the next edge is the smallest edge coming out of one of those three.
That's right.
Now Dijkstra's works very similarly. That's why we have this question. Yes, Matt?
So refresh me, Dijkstra's is shortest path tree, but Prim's is minimum spanning tree?
True.
Okay.
But they both work very similarly. So let's go back to the question. There is a graph such that Dijkstra's algorithm and Prim's algorithm are both started at the vertex, and the first edge chosen by Dijkstra is different from the first edge chosen by Prim's.
Actually, that's false.
So you're saying it's false that they always pick the same edge?
Because they always pick the smallest edge coming out of the first vertex.
Yes.
Does Dijkstra start at a specific vertex?
Yeah, it's what's...
No, it's saying they both start at the same vertex.
Oh, no.
Okay, I'm gonna go ahead and give the answer to this one, because you're probably gonna laugh.
Son of a bitch.
First of all, it's true, but don't feel so bad, because if we start the vertex, if the start vertex has two edges with the same smallest weight, the Dijkstra's and Prim's can't make different choices, absent ties. However, they will always make the same initial choice. This is a bit tricky, so we accept the both answers on the test.
So this was one of his clever questions.
Yeah, clever. Now you recover from your heart attack and move to the next question. Okay, there is a graph. This is still question 5. There's 4 parts. There is a graph for which the Bellman-Ford algorithm will perform fewer update operations than Dijkstra's algorithm. Raise your hand if it's true. You're saying that Bellman-Ford will perform less update operations. Raise your hand if it's false. Raise your hand if you're clueless. I think that's... So, let's think about it. Dijkstra goes through, it updates, it looks at each, it chooses a vertex, it pulls it out of the queue, and it updates that vertex, and it passes through the whole graph. What does Bellman-Ford do?
Bellman-Ford brute forces and then checks like one edge at a time, right? It checks one different approach at a time, and if it makes it better, then it updates.
Well, it goes through and it updates everything, but then it goes through again and updates everything. And then goes through again and updates everything. And it could go how many times total? V minus 1 could be the total. What's the minimum amount of times, which could be a question on the quiz, that Bellman-Ford will run? 2. And it could quit early if what?
It found the path the first time. The very first update it has.
The updates didn't change.
Update didn't change. So how many times, so it has to run at least twice, because the second time there will be no updates, right? So how many times does Dijkstra go through the whole graph? How many times does Bellman-Ford go through the graph? At least twice. So who does the most updates? So the answer is go. Who's feeling better about this test now? Not quite. Okay, the part C. There is a graph such that the total weight of the edges found by Bellman-Ford algorithm can be less than the total weight of the edges found by Quickselect's algorithm.
Can we go over Quickselect algorithm?
Quickselect is simpler than Prim's. Quickselect is you just pick the smallest edge. It's the simplest algorithm ever invented.
Is it the smallest edge without making cycles though?
Almost. I'm sorry, what?
Is it the smallest edge without making cycles though?
Yes.
Okay.
That's the part that makes it not so simple. You just pick the smallest edge without making a cycle. But it's very simple algorithm.
So it's probably false because Quickselect's given them a spanning tree, which means locates the lightest edges no matter what. You can't get anything better than that. So Bellman-Ford isn't find anything with this.
So you're saying false.
Yeah.
Who says false? Who says true? Both algorithms find spanning trees. However, Quickselect's algorithm finds a minimum spanning tree. Is that what you said?
Let's see. Sorry.
No, not quite. Okay, part D. There is a graph such that the total weight of the edges found by Dijkstra's algorithm can be less than the total weight of the edges found by Bellman-Ford. These are hard questions, I know. Really makes you think. There is a graph such that the total weight of edges found by Dijkstra's. Now, what does Dijkstra find? Let's think about it. Does Dijkstra find a tree?
Yes.
Yes. Does Dijkstra find a minimum spanning tree? Does Dijkstra find a spanning tree? Yes. So it's a tree, it's a spanning tree, but it's not necessarily a minimum spanning tree. Right?
Bellman-Ford also.
Bellman-Ford,
But they both return the smallest one, right? So.
they both return the smallest what?
Shortest path tree.
Does both return the shortest path tree? Is it possible to have two different shortest path trees?
Yes.
Yeah, they're equal. Then
Yeah.
by the same way.
I mean, could I have two ways to drive somewhere that are the same lane?
Yeah.
So what would the answer be? Yeah.
I just wanted to ask, so when it says found, does it mean like the path returned, but just like everything it had discovered along the way to its answer? So she's like,
Where's found at?
total way to the edges
I
found.
think it means in.
As like a stupid.
Just thinking in a little more detail. It's just adding up all the edges.
That were touched, or that's...
No, that it shows. Because when you choose a spanning tree, you choose certain edges, you create a spanning tree, and then you add up all those edges. So what is the answer? True? Raise your hand. False?
What?
Nobody. Wait, how many true hands are up? Like two? Matt's doing this.
Well, no, I had a question, like,
Yeah.
is it because Dijkstra doesn't work on negative edges or whatever? Bellman does?
Two different shortest path trees can be different total weights.
No, they can't. They can be
It's
different
of the
paths,
same
they can have
graph.
different weights.
But they choose to.
But isn't this a
This is a weighted graph.
It's not a minimum spanning tree, it's a shortest path tree. Two minimum spanning trees are going to be the same weight. Two shortest path trees could have different weights.
You show us an example of this.
Now I got to think of an example. Man, I should have had an example ready for this one.
Wouldn't that just mean one?
Yeah, if you're looking at the same graph, if I'm running a test in a program to find the shortest path, and I'm checking against, by shortest path, do they mean like the least amount of vertices you visit? Or the least amount of weight that you hit from one end to, or from one vertex to another?
Dijkstra works on a graph, right?
Yes.
So,
One click or two?
yeah,
For what?
Sketch.
So,
You
yeah,
just said one click and you can pick whatever you want.
you wouldn't have two different shortest paths.
Okay, I'm going to attempt. I can't promise you I can think of one because I haven't thought about this, but I'm going to try to create one. Let's see. How's this going to work? Can you think of one?
I didn't think I was gonna do it.
Oh, okay.
One of them would just do
You're going to have to let me think about this one. I can't think of one right now, so at the end, when we get to the end, I'll try to think of this one. Which question is it? Question 5D. So we're going to come back to this one. Okay, let's go on to question 6. If it were proven that every algorithm for factoring an integer n must be omega n in the worst case, would this imply circle 1? Now when it gets to this p equal np, sometimes I even get a little confused. So sometimes it can rack your brain. Remember, there's always a best case, an average case, and a worst case, and you can get the upper bound and lower bound on any of those cases. So it can get really complex. We're asking for the, if you recall, let's go back to, I should have had this picture. Oh, actually, it's way back here. There. So just to get a review of how the picture looks, NP, P, and NP complete. You guys didn't see that, right?
Sure.
No, never.
Okay, everyone saw. So P doesn't equal NP. If there were proven that every algorithm for factoring an integer n must be omega of n, in the worst case, would this imply? Now, if you remember factoring, you're dealing with the number of bits that are involved. And here we're dealing with the actual, here we're dealing with n, which is the actual number. And integer n must be omega of n. It's saying the smallest it can be. If you're dealing with bits, the complexity is going to be smaller, quicker than omega of n. This is saying the fastest it can be is omega of n. And when you deal with bits, it's going to be a complexity of log n. So, In the worst case, would this imply? Let's see what I put as the answer. The lower bound of omega of n would imply that factoring requires exponential time, since n equals 2 to the log n is exponential in the length. So if you limit your time to just n, and you don't go down the log n, then it's implying that it's exponential. Factoring is NP, if you recall, but factoring is not NP complete. Factoring is in NP, but not NP complete. You know, you have the circle NP, you have P inside of it, then you have NP complete, which kind of cuts the corner, but there's a lot of other NP stuff in there that's not NP complete. Factoring is one of them. No question? Okay, if an O of n to the 100th algorithm for solving the subset sum problem were discovered, where n is the total number of bits required to represent the set, would this imply? Anybody have a clue? A? P equals NP. B, P doesn't equal NP. Raise your hand. And neither? That is correct. For the few who answered. This discovery would be of a polynomial time algorithm for an NP complete problem. If you notice, n to the 100 is polynomial, so that's why it would be considered polynomial. And one more of these. If it were proven that every algorithm for solving the Hamiltonian cycle problem on a connected graph must be omega of 2 to the e, in the worst case, where e is the number of edges in the graph, this would imply P equals NP. P doesn't equal NP. P doesn't equal NP. We would have proven that not all problems from NP can be solved in polynomial time. Yes?
Can you explain what you mean by omega to the e?
Omega mean is the lower bound.
So that's the minimum time it takes.
Minimum time, the fastest. So big O means that's the upper bound, it can't be faster. Omega is the lower bound, it can't be slower.
So then for P equal NP, it's the average case that has to be polynomial, or the best case? Because that's polynomial to the e. So if you exclude worst case, to the e.
Yeah,
If-
easy
oh.
number of edges. So instead of 2 to the n, it's 2 to the e, which is exponential time.
Okay.
6, 7.
Question 9. Suppose that A and B are search problems and A is known to be NP complete. You want to prove that B is also NP complete. Which of the following should you do? Raise your hand if it's A, B, three people pick B, C, D. Okay, those are the crazy answers that should not trick anyone. So it's out of A and B. The majority picked A.
Oh wait. Sorry, guy.
You're going with A now? Okay, who picked B? Nobody? You're still sticking with your answer? It's A. Okay, you always reduce from A to B. Okay, solve for x in each of the modular exponential below, modular equations below. In each case, x must be positive, greater than 0, and less than the modulus. So what would be the first one? 6. That'd be 30 mod 7 would be equal to 2. Everyone agree? Anyone disagree? What's the next one? 0. Okay, I think you ought to read the question again. I think it says greater than 0. 4. 16 mod 8 is 0. Oh man, sorry. Sticky finger. What's the next one? 8. Man, that's the one I wanted people to work on too. So the inverse, why is it 8? Anybody want to explain why it's 8? Am I acting like I didn't put it up? What is the answer? Anybody pick 8? Nobody? We want to find a multiple of 7 that is 1 more than a multiple of 11. And if you multiply it by 8, yeah.
I was going to say, because 7 times 8 is 56, which is,
7 times 8 is 56.
and that's 1 more than 55.
1 more than 55. So, Joe is expecting you to be able to do these in your head. You should be able to do an easy one. So just remember, you're looking for the inverse of 7. Look for a multiple of 7 that is 1 more than a multiple of the mod. Here are 4 of the steps in a secure electronic commercial transaction. The browser encrypts something with an AES key. The browser encrypts something with the RSA public key. The browser requests a digitally signed certificate. The browser decrypts something with an RSA public key. Put the 4 in order, beginning with the one that happens first, ending with the one that happens last. So what would be first? B? Raise your hand if it's A, B, C, D. So it's not a B and C? It's C. So the first thing we're going to do is browser request that. I would suggest to go back and review the RSA slides. I was thinking about putting some of those in these slides, but you know, I couldn't put everything from a semester of slides into this one slide. Plus, I didn't have time. So I would definitely suggest going back and looking at the slides on this to help you to see what order everything comes in. Because I can almost guarantee there's going to be a new question on this quiz referring to this. So what is going to be next? So we did C first, where the browser requests a digitally signed certificate. So if you're requesting a digitally signed certificate, what do you think is going to happen after that? Now this isn't everything. This is maybe a list of 10 things that it just picked out 4 things. So you just got to figure out, there may be a couple things that happen before the second answer. It's just what's second in this list. So don't get confused by that. Yes?
Would you mind going over what an AES key is? I feel like I've never heard that.
Say that again?
The AES key? I don't remember that at all.
That is the key that swaps everything, where it ands everything. That's the fast key. RSA is the key that can be digital, that has a public and private key. The ESE is the fast key that after you've decided on an ESA key, AES key, then you can decrypt and encrypt using this key very quickly.
So that's the key.
There's been tests on that, and if you don't know that key, it's hard to decipher anything. Yes? What was
That's the one that we exchange over RSA.
Yeah, that's what you exchange, and then the AES key is what you use to decrypt your data. The RSA is just how you're picking the key. You got to find the key and then send the AES key is the one that's using the encrypt and decrypt all the data that you're going to be sending. So that's fast.
One B, right?
Who says B? Who says A?
Well, A
Who says D? So it's between C and A, and it's D. So D, we verified decrypt the certificate with the certified authorized public key.
Okay.
So they're going to send something back, and they're going to encrypt it with their private key, and you're going to decrypt it with the public key. And how do you know that it was sent from that specific person or company?
You have the certificate.
Because if they signed it, or however you want to put it, encrypted it with their private key, then it can only be decrypted with the public key. You got to remember the E and D. If you encrypt it with an E, you can decrypt it with the D. They just go back and forth. So one's private and one's not. And so if they have the private key and you have the public key, if they encrypt it, anybody can decrypt it. Anyone. But it lets you know that they are the ones who encrypted it. So that's where the law for signing came in. Someone knows that someone signed it because they signed it with this key, and when you decrypt it with the public key, that verifies that they signed it. Because the only thing that be decrypted with that public key is if somebody signed it and encrypted it with the private key. Okay, raise your hand if you're lost. Everyone's got it? Okay. Okay, so this one, what was that?
Just lost in general.
Not this class in general,
Just the whole class. So we verified, decrypt the certificate with the certified authorized decrypt. So we're decrypting the certificate with the certified authority's public key because they encrypted it with their private key. Okay, so what happens next?
B, please.
Raise your hand if it's B. Raise your hand if it's A. It's still 50-50. Make it B? Make it. Should I? Thank you. Okay, we generate an AES key. Now the AES key is what we use to do what?
To do fast and to communicate. To pass data back?
Well, encrypt and pass.
To encrypt the data that you are passing back. To decrypt and encrypt. So we generate an ASE key, encrypt it with the server's public key that was contained in the certificate and send it to the server. Because they need an also copy. So we're creating that key and we're now sending it to them so they can decrypt it. And now we're going to send it back and forth. It's the same key to encrypt and decrypt. And then A is the only one left. We communicate by encrypting with the ASE key.
Because now both parties have it.
Now both parties have the AES key. Yes?
So you said that these four steps are part of like a bigger set of steps?
Yes,
So
yes. This is definitely not all the steps.
Where can we find those 10 steps? Because when I first went through this exam, I watched the RSA video twice and then re-watched the section on the end where he talks about the e-commerce like 9 times, and I can't get this right.
Well, I just...
Like he doesn't, it's like kind of confusing. Even on the last example he says the browser encrypts AES key as the first step. So,
I don't know the exact name of the PowerPoint, but I can go look and I'll get back with you.
okay.
Just send me a message and I'll get back to you and tell you exactly which one. I'm not saying there's exactly 10 steps, I'm just saying there's more steps.
This is just like
There's just a subset of the steps. Question 12. How are we doing on time? 3 o'clock. Huh?
We go.
Does anybody want to take a break? You do? Okay, let's take a 5-minute break. Let's take a 5-minute break. This is really difficult on our brains. Let's take a 5-minute break. Go. Okay, question number 12. Suppose that you need an algorithm that can find the k smallest elements in an unordered array of n integers. Give a tight upper bound in terms of k and n on the expected running time for both of the following algorithms. So the first algorithm is sort the array using quicksort. Copy out the first k elements. So what is the complexity of quicksort?
It's n squared. Well, no, it's n squared worst case.
Yeah, so it should be n squared.
We're talking about upper bounds. So n squared.
Upper bound?
Right?
Maybe n log n. So
Now we would need to copy out the first k elements. What's the complexity of that? K?
So it's K and unless it's worst case squared plus
Well, no, it's n squared plus k.
Can we talk about the, what it means by tight upper bound?
Yeah, I don't know what tight upper bound means.
Tight upper bound means, let's say that the complexity of something is n squared. I could say it's O of n cubed, it's O of n to the fourth, if it's O of n to the fifth, those are loose upper bounds. But if I say if it's O of n squared, that's tight.
So is that what we traditionally think?
Yes, we traditionally think tight, and Joe will often say tight, just to prevent someone to say, well, O n to the fifth is still right, but it's not tight.
That's a loose case. That's a worst case.
Anybody have any answers? Yes.
Oh, just another question. When we're talking about upper bound on questions like this, are we supposed to answer with worst case or like average case?
I figured that was coming. And I'm assuming, I should have put, rather I had a note on here, I think this particular answer says that it's for average case.
Okay. Well, it says upper bound.
Yes?
wouldn't it be safe to assume that it's average case since it's saying the expected running time? and
Yes.
Since on average.
Exactly.
that gives it away.
Yes, that seems reasonable. Any other questions? Anybody have an answer? Yes? Apostle.
Big O of n log n plus k.
N log n plus k. Raise your hand if you agree. N log n plus k.
Well, probably just be
Can you remove the K?
What do you,
No,
Well, no, because
since n is bigger than k.
you're saying remove the k?
Yeah, because n is bigger than k.
Okay, and she's saying remove the k. Who wants to remove that k?
Don't.
Who thinks the k is a waste of time?
I can't convince me otherwise.
Did you have a question? Hold on, you guys, hold on. What's that?
K is smaller than n, right? So
Yes,
you can drop K.
yes.
But could K be as big as
It
n?
could be n, but it would still be n log n.
That's still n log n.
You would ignore n.
2 n, you drop the constants.
So what's the answer?
Why do we?
Listening to you.
That's
Should we jump ahead again?
n log n.
Because
K is always faster than k, for example, so it's basically.
Well, like I said, k is going to be dropped. You know, really it would be n. And it's, you know, 2n log n is just n log n. Yes.
Would we, like, because it says in terms of K and n, so if we have an O of n log n plus K, would we have it not?
Yeah, because that's how I did it.
Probably.
Because technically it says in terms of.
You probably would get a point off, I would guess.
That's not wrong though.
Because when you're talking about big O's, you need to drop insignificant parts. Just because it says you can use K doesn't mean you have to.
It's kind of misleading though.
How does it add with
No,
it?
it might have been K log n. You know, who knows? It could have been K log K. Who knows?
You know.
I mean,
See, but then on the quiz, like, if you didn't specify,
Just a more precise answer.
okay, so use Quickselect. Who? Yes.
So
In this case, we're dealing with average case. Are there any words that we can look out for in case like Joe asks us about maybe like lower bound or?
If you're unsure on the question, just raise your hand and ask. So yeah, don't get tripped up on that. And if I don't even know, if it's not obvious to me, I'll just ask Joe. He made the test. Yeah. So yeah, don't miss it because you didn't understand it. Always raise your hand. So, and this one, I think the key, like he said, was expected. Who's going to expect the worst case? Who's going to expect the best case? You're always going to expect the average, right? So that was the giveaway. That was a good. Whoever said that, that was a good catch. Yeah.
If it's average, shouldn't that be data? That should be a sticker here.
No. The case is different than the running time. You can have the best case, the worst case, and the average case, and you can have an upper bound or a lower bound on any of those cases. Now you're just more confused, right? The best case is the situation that allows this algorithm to run the fastest. The upper bound would be what's the worst case, or what's the highest complexity of that best case, and then the omega would be what's the best of that worst, best. Now I'm getting confused myself. If you're talking about the best case, you can have the big O and omega on just the best case. Then you get the worst case that could be n squared, for example. That you could have the omega and big O on that also. Now it's not usually likely to use them all, but I'm just saying they're all possible. Gotcha. Okay, use Quickselect. What is Quickselect? Let's stop on that second word. Does anyone remember Quickselect? Raise your hand. Quickselect was an algorithm that allowed you to pick the kth item, or the location of the kth item in an array. And what it does is go through the array, and everything bigger than k it puts on the left side, and everything larger than k it puts on the right side. So you find out where k belongs in that array, and you know everything below it, before it is below, everything after it is above. They're not in order, but you have k in the proper position. So what is the running time to this algorithm? See, you need to know this to answer this question. You want to take a shot? I kind of gave it away at the beginning of the explanation.
That'd be linear.
Linear. You just run through one time, and if it's greater, you know what k is. If it's greater than k, put on the left. On one side, it's smaller than k, you put on the other side. And you just have to run through the list one time. It's linear time. So, now that you remember the Quickselect, I would go back and study that, or remember from me telling you, and put that in your notes. Use Quickselect, the randomized selection algorithm that we studied, to find the kth smallest element. Use this element as a pivot and partition, using the partitioning algorithm from Quicksort. Copy out the first k elements. What is the complexity of that algorithm that I just explained? Yes?
Linear or O(n)?
Okay. Who agrees? Who disagrees? Who's not committing to an answer? Let's see if, since he's the only one who is stepping up to the plate, let's see if he's right. Good job, man. Does everyone understand that? Any other questions on that question? If Quickselect is n, finding the first k elements is n, 2n. Yes?
So how, say we were to put plus k on there, because that was the thing I got kind of blindsided by, was I didn't realize that.
That's the same as the other one. That, I would suspect that we would take off. How many points is this?
6.
6, 3 points for each one. We'd probably take off a point if you put extra unnecessary elements, insignificant elements to your complexity. Yes?
Can
he word it as in terms of K and or N, possibly?
That you have to talk to Joe. He writes the test.
It just feels like, oh, I need to use both. When I read
It's.
the question is requiring you to figure it out.
I agree with you. It's implying that you have to use K and N. I understand, but just remember that you don't. This is the way Joe. Let's read it again. Give a tie number bound in terms of K and N.
Just maybe mention it to Joe. That's great.
I'll mention it to Joe. He could say, well, if I said mentions, I'm trying to create an argument against that. Well, if I said to give me the complexity of something that is constant in terms of N. Do you have to use N? You say O of 1, right? Because I'm not saying it's constant. I give you an algorithm. I say, give me the complexity of this in terms of N. Are you going to say, well, I have to use N, so I can't answer the question because I have to use N? You're going to say, no, it's constant. It's O of 1.
No, if
you didn't have to use it.
Complexity in terms of K, that's like a different question than in terms of.
Well, but you can't use K. You can use N. I'm giving you the argument that Joe would probably give you. He could possibly put K and or N, but I think he may feel that A, it might be unnecessary, and B, that it might be implying something that he doesn't want to give away.
I think this is implying something that he didn't intend.
True. But now you know. Each row of the table below gives bounds on f of n and g of n. At the end of each row, indicate whether the bounds on the row imply that g is O of f, or f is O of g, or neither. This is hard. I'm going to put it this way. This seems easier than it is. Because if you have an answer, you're going to think for sure that it's right, and then it's not. So let's look at the first one. F is O of n. Squared. G is O of n cubed. So is the answer G is O of f, F is O of G, or neither? Raise your hand if G is O of f. Raise your hand. G is O of f. Raise your hand. Just a couple. F is O of G. Raise your hand if it's neither. What? What? Okay, do you see that hint there? What does the hint say? How many clips? One?
Just hit one.
Oh, because that could be O of n cubed too.
So what if something was n cubed, it could be here at n, right? And if something in here could be n squared, right? So you can't, if this is f and this is g, and my algorithm was n, I cannot say that just because n here is still O of n cubed. And this n squared is O of n squared. So I can't say that f is O of G, because G could have been in.
Well,
G could be constant. This algorithm could be constant. And I can't say that this n squared is O of G if it's constant. Okay, let's look at the others. It'll make more sense.
So basically, if there's two O's involved, you should just count it as two.
That's probably a good way to put it. If there's two O's involved, neither one, when we moved on, you were going to see that, but you already figured it out. So, both bounds cover a common area. That's my note, so I hope that makes sense.
so since f is O of n squared, then f is also O of n cubed, right? Am I right when I say that? Since f is O of n squared, it includes basically everything above it. So f is also O of n cubed.
No?
It includes everything below.
Everything below it.
So then G would be.
If f is O of n squared, it can be n squared, it can be n log n, it can be n, it can be constant. It's anything. Now, if it were tight, it'd be n squared. But things aren't tight here.
O of n squared. That doesn't mean it's O of n, right?
No. If it's O of n squared, the complexity, if an algorithm f is O of n squared, that means the complexity upper bound is n squared. So it could have a complexity of n squared, n log n, constant, because it just means the upper bound is n squared. But it can be anything that is lower. So when we look at the next one, f is n squared, g is omega of n cubed. So is g of O of f? Raise your hand if g is O of f. Raise your hand. How many? G is O of f? Any hands? F is O of g. And neither. Because all of G is greater than all of F. Okay, F is the third line. F is theta n squared. G is O of n cubed. Raise your hand if G is O of F. Raise your hand if F is O of G. Raise your hand if neither. They both share a common area again. You got F is just n squared only. G is n cubed, which means it could be anything from n cubed down to constant, for example. So they both share a common area. So it's neither. G could be greater than F. G could be smaller than F. G could be the same as F. So neither of them can be O of. Neither can be O of the other. Okay, let's look at the last one. F is theta n squared. G is theta n. Which is bigger? Is G of O of F? Raise your hand. F is O of G? Neither. Raise your hand for neither. You guys never raise your hand for neither, and it's always the answer.
It's not this time.
It's not this time?
They don't have a common area.
They don't have a common area. Very good. Yes. Yes.
So in our common area, can they be equal to, or is O always less than?
Yes, they can be equal to. When you're talking about O of, it can be equal to. Equal to or less than.
Right, but if you have omegas, or betas for each, doesn't that imply that one is exactly n squared, one is exactly?
Yes, that does.
How can they be equal?
No, equal to or less than.
So I see it as just less than, it's not possible. And less than.
No, when you talk about just less than, you're talking about little omega.
Right. So like for the second one, that makes more sense to me.
The second one, what?
It should be little o, little o g.
No, but we're not using little o. We're using these, and what's the answer for these?
Right, so like,
If you use little o, it would be a different question.
but is that true statement f is less than or equal to g?
When you're saying f is o of n squared, it means it's n squared or an easier complexity, a smaller one.
Right, but if g's minimum is n cubed, then there's no common here.
That means that, yes, exactly. That's why it's f of o of g. Because omega of n cubed means it's n cubed or higher. And f of n squared means it's n squared or lower, and there's no common area. So anything in f was going to be o of anything in g. Yes, Matt?
Okay, it says big O bounds are not necessarily tight. Is that also true for theta? Because I think of those as being tight.
Yes, they are. Well, theta means if you're saying it's n squared, it's not. It is exactly that.
So theta and bounds are tight.
Right.
Okay.
Now, with the exception of the small part of the computation that you draw for big O terms. Any other questions on these set of questions? Yes?
So for like the first one, if something is O of n squared, it's also O of n cubed, but that's not f of g because...
No, that's not true.
That's not true.
If something is O of n squared, does not mean it's also O of n cubed. If it's O of n squared, that means O of n squared is the upper bound.
Right.
It's n squared or less than.
Right.
So it is...
But it would also be O of n cubed.
Yes, I'm sorry. You're right.
Right.
It's also O of n squared, which would be a loose upper bound.
Right.
There's also O of n to the fourth, which would be even looser.
But so the first one is neither because, and this is what I'm unsure of, like there's a point, because you're not bounding it by cube, you're bounding it by the function, like the other bound.
Okay, let's imagine, it's saying f is O of n squared. So let's imagine that f is n squared. If f is n squared, is it O of n squared? If the complexity of f is n squared, can we say it's O of n squared?
Yes.
Okay. G is n. Is the complexity of O of g cubed? In my example, g is n. Can we say it's O of g cubed? Yes. So is f O of g? No, because f is n squared and g is n. So it can't be O of g. Think about all the possibilities of what f can be and all the possibilities of what g can be. Yes?
To clarify on that, if you see O of n squared, it's like n squared or more, so it could be n cubed, fourth, fifth, or is it?
No, O of n squared means it's n squared or less. That's the upper bound.
So you can't go n fourth, it's going to do n half n to less, right?
It means the complexity. If you say f is O of n squared, f is n squared, the complexity of f is n squared or less.
Yeah.
But you could also say f is n cubed if you wanted to, but we don't want to look at that because f is n squared. F is O of n squared. So just think about all the possibilities of what f can be. It can be n squared or anything less than that. On that particular, on the second one, g is omega of n cubed. It's n cubed or anything greater than that. So all the possibilities of g are greater than all the possibilities of f. So f can be O of g. Pull your hair out. Ugh! Any other questions on this? Is this part easy? Does this make sense? Does everyone got this section now? Raise your hand. Copacetic? Raise your hand, it's still a little shaky. A little bit? Okay. Shall we move on? Do you have any more questions, Sam? Okay, let's move on. Question 14. Suppose that you have a rope that is m meters long and that it contains n knots. This is a typo. You want to cut the rope into the smallest possible number of pieces, such that no piece has 2 knots that are more than 1 meter apart.
Seems greedy.
Everybody thinking greedy at this point? All cuts must be made. All cuts must be made between knots. Is this problem best solved by dynamic programming, greedy, or divide and conquer? Raise your hand if it's greedy. Do you have a question?
Yeah, I have a question. So when it says best solve, is it saying, like, assuming there is a greedy algorithm, or like, what is, like, I'm confused about what it means by best.
Best means what's the easiest way to solve it. You can solve TSP on an algorithm that may take 20 years.
So it's saying
Or you can solve
be
it
solved
in
any
10
of
seconds.
these ways, right?
I'm sorry, what?
It's saying it can be solved in any of these ways.
Yes, it possibly could be solved in any of the ways, but what is the easiest way?
Right.
The best, the easiest.
So, sorry, so just to like bridge off of that. So if this said instead, like you have a traveling salesman, and all these ways worked. We all know traveling salesman doesn't have a greedy algorithm, but in the context of this question, it did. But really, greedy algorithm would be the best.
You want to use greedy algorithm. Greedy algorithm is the best way to do something. It's the fastest. So you always want to check, you know, if it can be done as a greedy algorithm.
Yeah. So then, why was this in the question? If there's greedy algorithm as an option.
Well, maybe this set up a question. It's asking you, can you use a greedy algorithm? Basically, that was the question, and the answer is yes.
What's the greedy choice then?
The greedy choice? Simply cut between the knots that are more than 1 meter apart. Got it?
Yeah.
He's still.
I buy it.
Takes a while to think about it, huh? Any other questions on this? None? Let's move on. Okay, question 15. Suppose that a weighted, undirected, connected graph contains V vertices and V log V edges. V vertices, I always stop and let it sink in before I continue reading. V vertices and V log V edges. That means there's obviously more than V edges. Well, if you got 10, let's say you got 10 vertices, you may have around 13 edges. A little more than the number of vertices. Using O notation, give a tight upper bound on the time complexity of Dijkstra's algorithm on such a graph. Assume that the graph is represented with an adjacency list and that the priority queue is represented with the binary heap. What's the complexity of Dijkstra? V log V. I've calculated this before. I didn't have time to put the calculation in the PowerPoint. I apologize. So you would have to see me later for the exact arithmetic calculation to get the answer. Anybody want to take a shot? No? None? Yes? 2 V log V, Matt?
V log V.
Just V log V? Anyone else want to take a shot? Just take a guess. V log V is the answer. Did you know it or you guessed?
I think
Let's listen to what he's got to say.
I think about the time complexity of Dijkstra algorithm, and we have V log V edges, so I use the formula.
Okay. Yes?
That's the time complexity of Dijkstra's, it's E log V, right?
No, it's E plus V log V.
E plus V log V.
So then you substitute in.
Substitute the number of edges in there. That's it. See, that's the part
Yeah.
I'd done before and I couldn't remember.
V log
You
V
sub-
squared or V log
Right.
V.
E plus V log V. You substitute V log V in for E.
So then you get 2V log V.
Yeah.
And then you get rid of the constant.
So you
2 is
get
constant.
So you get V log V with V log V inside it.
Yeah.
That's
Why would it be next to?
Because you're plugging in the number of edges into the complexity of Dijkstra's.
Right, but we just said that it was E plus V log V, not just V log V. So it's V log V plus V log V.
V log V log V log V log V plus E. I think, I don't know.
See, I didn't have time to write an explanation, so I apologize.
Can we get one of those?
I'll get one to you later. I'll work it out later, and possibly I'll try to put it in the PowerPoint before I post it. Is everyone keeping track of everything I have to add to this?
No.
Just you have to fix the reduction slide.
Oh yeah, don't
Fix
forget
it?
Don't forget to fix the reduction slide.
Going from.
Oh yes, I need to fix the reduction slide. It was late last night. I was typing it, and
That's the one thing Joe said.
I said, don't forget that, and then what do? I forget it and give it to you wrong. But see, you guys all caught it.
It's good. Imagine there's what, like half the class got it wrong.
We won't cut.
But you saw me when I started reading it, I stopped. I'm like, because I knew it was wrong as soon as I started reading it. So, question 16. We got 2 questions left.
Yes.
Almost done. You are the commander of an army. I remember the answer we had. There was another question like this that was very similar to this. I think for a final that came after this one. This was the final in 2011. So it's slightly different. So think of ways you could alter this question or any of the questions and create your own questions and see if you can answer them. That's one way I would study. You are the commander of an army. At 8 a.m., you intercept an encrypted message intended for the enemy commander. The message is encrypted via RSA using the enemy commander's public key. The message is encrypted via RSA using the enemy commander's public key. How do you decrypt something that's encrypted with the public key? Huh? You decrypt it with the private key. You know his public key, but unfortunately you don't know his secret key or private key. The key pair was constructed using 81, 92-bit prime numbers. Your spies have determined that the original message was either attack from the east at noon or attack from the west at noon. Is it possible to expect that your encryption specialist will be able to figure out what the original message was in the 4 hours remaining before the attack begins? Yes?
I feel like some of these questions can be ambiguous in the fact that it's like, is it possible? You're like, well, is it possible? Well, the quantum computer, sure. Anything's possible, so.
Possible with stuff we have in this century.
Okay. You get really, really lucky. First thing you try.
Say that again?
You could get really, really lucky. It could be the first thing you try.
It doesn't say.
Bam.
It doesn't say, is it possible though? It says, is it reasonable?
No, definitely not reasonable.
Yeah, who said possible? Sam?
I
did?
Yes, you did, I heard it.
I said it?
You said
We
possible.
have it.
Oh, you're right.
Is it reasonable? Ooh, I'm so wrong. Is it reasonable to expect? Who says yes? 3. Who says no? Who's going to get attacked from the side they weren't expecting? They're coming this way. So.
Because, okay, hold on. Is it because you know what the two possible messages are?
Yes.
Okay.
You know it's one or the other. What did you? Okay, can you repeat that?
So you can encrypt both the messages with the public key and see which one matches the encrypted message that you got.
Exactly.
You should encrypt the same thing.
Are you guys hearing that? Did you guys hear that? Okay, she's going to repeat it one more time.
Boy.
Because she's so smart, she figured it out.
Because you have the public key, you can encrypt both messages, and one will match the originally intercepted encrypted message. Because it was encrypted with the public key as well. So you have the message and the key. So you can.
She got it exactly right. Simply encrypt both of the possible messages and see which one yields the encrypted message. Nailed it.
Got one question.
At least you didn't get a 0.
Yeah, there you go.
So you got this RSA thing down, right? You got that.
It's actually the one I struggle with. All the other RSA questions.
This, okay. This one you had a 50-50 chance of getting it right. Okay, last question. Consider the problem of determining rather, now you guys did a lot of homework based off this stuff. Which assignment was it? Do you remember? Was it 11 or 10?
They're all over.
The one that we were in your office for.
And you had to grab the first section and the recurse on the second half. This is the same kind of thing, where you have to determine the first and recurse on the second half. Okay, consider the problem of determining whether a string S consists of a sequence of English words for example, black and blue does, but black and blue does not. Black and blue does, and black and blue does not. Here is a greedy algorithm for this problem. If S is empty, report true. Okay, remember that for later on in this question. If S is empty, report true. It's the same as that other one. Remember, if you were at the end and there's nothing left, it's true. It's 0 or more words that are in the dictionary. Remember that? So if S is empty, report true. If S does not begin with an English word, report false. Otherwise, remove a word. This is just an algorithm. This is one algorithm. Remove a word with which S begins and returns the result of running the algorithm on the reduced version. Is that a good algorithm? No. It's not a good algorithm. It will work sometimes, right? But it won't work all the time, correct?
Yeah, right.
So, unfortunately, this algorithm does not work in all cases. Give a string on which the algorithm will fail.
So I can't think of an actual string, but you just need a word, or you need a word, or sorry, you need a word that starts with a real word, and then when that's removed from the string, the remainder isn't a real word.
Exactly. That's exactly true. He said that to get one to fail, you need a string that will grab a word, and when you pull that word away from the string, there's not a word left. But the part he left off, but in fact, the whole thing does consist of words. That's the part he left off.
Since it says if S is empty, report true, wouldn't just an empty string also report true and then fail because it's looking?
Well, if it's an empty string, it's true. If you grab all the words and report on what's left, which is nothing, it would report. Well, no, that wouldn't work. It's just if it's initially empty, it would report true.
But if you started with an empty string, wouldn't it would say yes? Like, wouldn't it say true? But that would actually not be correct because.
No, because the algorithm says if S does not begin with an English word, report false. It says grab the first word and then pull the word away. Okay, so can anybody give me an example of what would cause this algorithm to fail? Yes?
Blues.
Huh?
Blues.
Blues? B-L-U-E-S? Can you explain to me why?
Because it would pull out blue, thinking that that's a valid word, and S would be left over, which isn't a valid word, even though blues is a valid word.
That's exactly right. Anybody else have an example? Yes?
Yeah, with at work,
A what?
AT.
A-T, at. Anybody else have an example?
Interpol.
Inter what?
Interpol, you know.
Okay. Did someone raise?
Oh, bear.
Bear? Yeah, it would pull out B. And AR is not a word. What's the smallest word that you can think of that would work?
Is.
Is, at, or and. It doesn't matter what word you put in there, as long as there's a word that will cause it to fail, you'll get it correct. Okay, the second part of this question. Having failed to find a greedy algorithm, let's look at a dynamic programming algorithm. Let's assume that S contains n characters, S of 1 through S of n. We're not starting at 0. S of 1 through S of n. That there is a function dict that takes in S and I and J that returns true if and only if the substring I of J is an English word. So if I put in bear and I do dictionary bear and then put 1 and 2 in there, it would return true. If I put 1 and 4 in there, it would return true. Does that make sense? The reason I'm going over this in detail is because this is what you need to do when you take the test, is make sure you understand exactly how these functions work. Because a lot of people miss this. Let's define W of I to be true if the characters 1 through I consist of a sequence of English words. So 1 through, if you say W8, that means the first 8 characters consist of English words. 1, 2, 3, or more. But they all consist of English words. Here's the skeleton of the recursive definition for WI. So W of 0 would be true. The idea for the recursive case is to try out all possible places for the final work break in S1 through I. There are 4 blanks in the solution going top to bottom and left to right. How should the blanks be filled in? So what's the first blank?
True.
If S is empty, report true. That was in the explanation. What is the next one?
J.
Why J?
Because J has to be less than I, and you're looking at the subsequent, or you're looking at the substring S of 1 to I. And so you want to see if you have a subsequent or a substring of that substring from 1 to J that is also a sequence of words, and then you just look at from J plus 1 to I and see.
Now you're giving the answers to the others.
Sorry.
No, you're right, but let's just do this one. So he's saying it's J. Does anyone agree or disagree?
Sorry, what's J?
choosing this second blank.
What does J represent?
It's right here. J is equal to or greater than 0 and less than I. Actually, this is wrong because the string starts at 1. So that's actually a typo. Not mine, I grabbed it from the test book. So, he's saying it's J, which he is correct. Does that make sense to everyone? Any questions on that one? And now, what would the dictionary call need to be? He started to explain it, but I'm going to see if anyone else knows it. Anyone other than Sam? Anyone other than Anthony or Sam? Sam.
J plus 1 to I, because that's the remaining part of the string.
J plus 1 to I. There is a function, boom, that returns. Does that make sense to everyone? So this is very close to the homework that you had. That's it. Anybody have any questions? Yes?
You talked about the case where Bellman-Ford would have a lighter, shorter path.
Oh, I knew you were.
Yeah.
Did you think of an example for that?
Bellman-Ford would have a lighter.
True, it was
It could have a
25.
different shortest path, but it'd have to be the same weight, because they both find the shortest path.
So two shortest paths.
Paths of the same distance.
Oh!
Different ways.
Your answer,
different
your
ways
true
to
false
solve
is correct, but your justification for it is incorrect.
It's the same graph, right? Bellman-Ford would pick a lighter. Okay.
Because depending on the order that Bellman-Ford picks, like even running it back to back, shortest path.
Well, let's end the video and then I'll think about it. So, that's it. Thank you very much for coming. And we'll work on that question after we end.